Okay, hello. My name is David Rifkin. I work in developer relations at a company called Embrace, and with me is.
Francisco Prieto. I also work at Embrace. I'm an Android engineer, and we are currently working on observability for mobile.
Awesome. Fran, as I call him, and I have both been working in mobile development for a while, and so our work at Embrace is in the field of mobile observability, where we try to find out from production data what went wrong for users. And we're going to start by talking a bit about where observability fits in the mobile processes. And then we're going to talk about OpenTelemetry and how this shared data model can be applied to mobile observability. And then we are going to demo how to use OpenTelemetry in an Android app and what you can learn from your Android app if you use OpenTelemetry. So, Fran, ready to go? Before we show how OpenTelemetry works in practice in an Android application, let's talk a little bit about how Android teams tend to work before they put together a release and what observability means for those teams, and then we'll hop into the demo. So when an Android team is getting ready to release a new version, what are some of the normal processes that developers follow?
I think it's pretty common to have a CI that runs a suite of tests, usually unit tests, integration tests, more end-to-end tests. And then if you were working on a particular part of your code and a particular workflow, you will probably be testing that manually, either in one device or many devices. You can also be doing performance testing to see if everything is working smoothly. But I think the main point is that you don't really test it on many devices. You usually just have some devices, and that's it.
Cool. And then I guess what would be some drawbacks to only having unit testing or maybe testing the UI on emulators? What might a developer potentially be missing?
Yeah, emulators work great for development. You don't need a real device to be doing your work, but once you actually want to see how it looks like on a real device, there are some differences. It's hard to replicate in an emulator things like network conditions varying, things like CPU not working as expected, or maybe a phone with lower resources. There are phones that have problems with their CPU, or maybe some thermal throttling, and yeah, it's hard to replicate that on an emulator. And as for unit tests, they are great for ensuring that your work looks great, and that a single component works great. But you can't really, or it is hard to test things like connections or things that are particular to each device.
Sorry, you have a cat running in the background. I have two puppies making noise, but yeah, I think that makes a ton of sense, especially about the scope of the unit tests. And just speaking about scope, when you're testing devices, is can you possibly test all the ones that you're going to run into in production? Is a number like 10 or 100, or what sort of multipliers do you have going on there?
No, it's a lot more than that. Android has so many manufacturers, so many OS versions. Users might even be using custom ROMs. It's like that's a big difference with iOS, where you have like fewer devices. We really have a lot, so it's not possible to test like every single variable um, without observability.
So I think that kind of points us to observability, and production data is important. I'm fighting off the dog again. So ultimately, with pre-release testing, what are you missing?
Yeah, I think you're missing some key points where you might be having trouble or where your user might having trouble or might have trouble. First, it's hard to test what the users are actually going to be doing with your app. You pretty much do some development thinking that the user is going to do certain thing, it's going to interact with your app in a certain way, and then the user does something completely different, or they might even, like, I don't know, navigate to somewhere else, switch app in the middle of navigation. It's usually hard to predict what they will be doing, and then even if they are behaving in the way that you predict, they might have a different device than what you expected. The device might not have a certain sensor that you expect to be working with. The device might be old, might be too new, and then even if the devices are what you expect, you don't really know how their network connection is going to be working. They might be in a Mether connection, they might be having some bandwidth issues. It's always hard to predict how an app is going to behave in the wild.
I think the last phrase, how an app is going to behave in the wild, that's why we want observability. That's why we want production data to make sense of it. So, just thinking of one user flow, if I'm checking out in an app, even just from the user interaction level, I can add an item to my cart. I can try to check out. I might stop there. I might not be able to put my credit card in for technical reasons. I might lose service and not, transmit the actual payment request. Like, one user workflow can end up with so many different states for so many different devices. What are the keys to figuring out, what's going on in production?
Yeah, I think that's the useful part about observability. You can focus on some key areas that you know that might be a bit hard to predict, or the users might be having some trouble in those areas. And then you can try to get as much telemetry you can about those areas, and then try to make sense what's happening when you have a crash or a bug or something like that. For instance, if you know that your app is going to be used in devices, all devices, you can try to get telemetry for the kind of devices the user is going to be using. You can get information like, is the user connected to a Wi-Fi network? Is the user using cellular data? They might be using a different hardware. They might be using a specific operating system. And then you might even get information about the thread they are on. Are you doing much work on the main thread? That's usually hard to test in unit tests or in the usual flow that you usually test before releasing. So having that kind of safeguard, it's usually great.
Yeah, so you mentioned the main thread. It's something that is active at runtime, but you might miss it when you're doing your TDD, when you're doing your UI testing. Why is it so important to figure out what's happening on the main thread?
Yes, I think it's easy to have bugs that aren't tested when you're working with threading, because the usual tools that you use for testing aren't that compatible with testing what's happening on each thread. And it's incredibly important because it's the main thread is the one that is in charge of rendering the UI. So it's the first thing that the user is going to notice if it goes wrong. So if you are doing too much work on the main thread, if you are doing some input outputs, if you are blocking it in some way, the user might face some stuttering, it might face some missing frames, and it might even cause an ANR where the app just closes because it can't render correctly. And this is important not only because it's a bad experience for the user, but also because of the Google Play rankings, where your app might be hidden or not shown as much if you have a bad ANR rate. So trying to figure out when this happens and how, it's incredibly important.
It's not just affecting your play status, but it's affecting the user looking at the screen. So I guess how ultimately, as a mobile developer, an Android developer, how are you using observability to create just a better product for a user?
Yeah, I think that's one of the impactful things that you can do is that you're going to get data from where your users are in your app, like from which flows are going to use the most, what parts of the app are most important for them, and then you can like give the importance that it's needed for that. You can pay more attention when you are developing something. You can spend more time developing a certain part of the app, and also it's going to help you solve bugs, solve crashes in a more deep manner. You're going to have a lot more context. You are going to know what the user was doing, what kind of device the user was using, what were the network conditions. You have a lot more information that is going to make your life easier when you need to fix something.
Cool. And then I guess the last question here is, we've been talking about observability. How does OpenTelemetry itself help you, add observability to your app and your production ecosystem?
Yeah, OpenTelemetry has some pretty specific advantages. That's why we are pushing for it so much. It is an standardized API, so you're going to be speaking the same language with your backend engineers, with your DevOps, with whoever is going to consume that data or is going to analyze that data. And one of the best things it has is that you own the data format that you're going to be using, and that's going to be compatible with any other tool that uses OpenTelemetry. If you're using a specific vendor to export your data to analyze your data, you can grab that data and take it to other vendor, and it's going to work great.
We're gonna hop into a demo here. So Fran, I'll give it over to you.
Nice. Let me share my screen. Okay, so what I created for this demo is basically a really small example of what you might find in using observability for mobile. Let's run the app so we can have like a general idea. Okay. So it's a telescope shop app. It's really simple, and it's basically a list of telescopes. Let's suppose you like telescopes and you just want to have a way to sell them. You can add, remove telescopes, whatever you want. And then once you check out, you see basically the telescopes. Let's suppose they just arrive magically to their destination. So it's a pretty simple app. Let me show it again here. And the structure of the app is also quite simple. It's a compose app. We have the main activity that creates this sort of navigation hub that it's using navigation compose for showing the screens. Every screen is written with compose. The confirmation screen, it's the one that we saw here. It's pretty simple, just some text and the telescope image that we are using all around the app. And then the telescope shop screen, it has the list of telescopes. Remember variable that is going to get every telescope that we add to the cart, and then place a column to show any telescopes we want. It's not too complex, and the idea here is to show what we can instrument with OpenTelemetry. So in order to do that, I actually created another branch. This is the not hotel branch, and this is the hotel branch. So let's go to that branch. If we compare those branches, we should be able to see what's needed to instrument your app. So pretty much we need some dependencies. Here I'm using version catalogs. We will be adding the versions that we need for hotel. It's basically a bill of materials with a lot of dependencies, context, OT exporter. We'll talk about the exporter later. The SDK and some semantic conventions. We use that in the build.gradle file. And let's go to the important part. So it doesn't change much the overall design of the app. It's basically just creating here, sorry, in my activity, creating a telemetry object. Here in this telemetry class, I centralized everything related to OpenTelemetry. So we have everything in a more closed space to have a look at. We are basically creating that telemetry class when the app is created and passing it to the navigation hub. In the navigation host, we are going to be telling the telemetry class that we navigated somewhere, and we'll see in a minute how we handle that. So here's the telemetry class. It's basically initializing OpenTelemetry and then handling all of the transitions to track navigation. The only thing that we are going to be tracking for now, it's navigation. So it should look pretty much like this. We will have a session span, and inside that session span, every screen that we go to is going to be appearing as another span. So it's going to be a, I don't know, navigation telescope shop screen. That's the sorry, here. That's this screen, and then the confirmation screen, wherever we go there, it's this screen, right? So once we get the overall look of how it should look, let's see how it works. We have a function that initializes OpenTelemetry. For this sample, we will only be using traces, just spans. For that, we are creating a tracer provider here, and we are passing it to the global instance of OpenTelemetry to be also used in this telemetry class. This tracer provider gets two different objects that we will be using. One is the exporter. This takes care of exporting everything to our backend. I'll talk more about that backend in a minute, but this is basically a Docker image that we created for this example. This exporter is being passed to the span processor, so every span that we create in this tracer provider is going to be exported using this. And then we have the resource. The resource is a structure that we can use to add more telemetry, to add more context to our metric, to our signals, be it metrics, be it logs, be it spans in this case. And what we are going to be adding right now is mostly the service name. This is pretty much standard to what you add to resources, and we are using semantic conventions here. Here, there isn't a semantic convention for screen resolution, but we will be adding these too. We're getting the device resolution from the resources. So every span that we will be sending is going to have the resolution associated to it. And then we build the tracer provider, and we just initialize it here. So the other thing that this class does is handles navigation as spans. So what we want to do is when a span, when the app gets opened like this, which we want to create a new span. When we enter a screen, we want to add it as a child span. And if we go to another screen, we want to close the previous span and get the next one. In order to do that, what we are going to do is add a lifecycle observer. This is going to notify us every time the app passes through the lifecycle event on start or on stop, and we are going to be calling our functions. So every time the app starts, we are going to create a session span and set the current navigation. The navigations might either be telescope shop screen or confirmation screen. And then every time the app stops, we're going to finish the spans that we are storing, one for the session span, one for the current navigation, and this is like a workaround to avoid the app getting killed before we get to export the spans. But basically we are finishing the spans, and that will make then be sent automatically by the exporter that we set up earlier. And then when the navigation occurs, we just store the current destination, and we finish the previous span, if any, and then create a new span as a child of the session span. How we do that? With the OpenTelemetry library, we just get the tracer, get the span builder. If we have a parent, if we are calling it with the session span as a parent, we are going to set the parent, and then we are going to start the span. It's quite simple. It's nothing too complicated, but it's like basic telemetry that you can use to know where your users are in your app. And how does that work? We might just do a checkout. How do we ensure that this is actually being sent? What we did here was we use a Docker backend. Let me show you the project. This is the Docker OTL LGTM. It's a tool by Grafana that pretty much opens in Docker. It creates a Docker backend with Prometheus, Tempo, Loki, and Grafana. We already have that running. So if we go to, let me check here, localhost, we're going to have a Grafana instance where we can explore our queries. We can use TraceQL to query our spans. Here is the span that we just created, and what we can see here is like this is the trace with the session span, and inside we can see that there are two spans, a span for the telescope shop screen and a span for confirmation screen. This is useful because if you extrapolate it to a bigger app, you can see where your users are going in your app, and you can detect what's going on with it. An example will be, for instance, in our app, what happens if a user has a smaller screen. Sorry, it's this one. So if we run our app in a smaller screen, we'll see that, let me check, is it here? Let me make this a bit bigger. Here we go. We can see that we don't have a checkout button. So we can imagine that our users will be like, will just stay here and that's it. They can't do anything else. And there's like nothing else to do. So in our spans, we will be seeing just spans in the telescope shop. We will never get the confirmation screen span. And what that will mean is that we in Grafana, if we do exactly the same query again, we're going to have spans with both telescope and confirmation screen, and we're going to have spans just with shop screen. And we have a lot of queries that we can use to actually look at where this happens. So for instance, we have this query that I have right here. So if we use this, we're going to be saying, hey, give me every session span that is a parent of a confirmation screen span. And this is only going to return one span. So let's suppose that you're doing this with a bigger app and you want to see how many of your spans actually have a checkout or actually result in the user buying something. You can use this. And if you want to check why the user isn't doing that, you could also add resources, add more telemetry to check what kind of user you are doing. So for instance, if this was a real app, we could see, hey, this user is actually using a screen resolution of 1080 2138, and the user that does not have a confirmation screen, we could check and say, hey, no, this is a way smaller screen. You can do this same exercise with a lot of other telemetries if something, and not even talking about errors, or maybe you can say, hey, the user was having, I don't know, the Wi-Fi deactivated, the user was on low battery. There are a lot of resources that you could add to your spans to actually do some some data analysis to check why something is going on. So with the attributes that we added, we can solve certain issues like this one, where for some specific devices we can't really reach a checkout button, or we can't really reach a certain destination, and then with Grafana we can say, hey, this is what was happening.
So yeah, it looks like in your Pixel device emulator, the resolution is large enough that they can actually check out, but in the Nexus emulator, I guess the product engineers haven't accounted for the screen size, and therefore the user won't be able to reach that confirmation screen. Is that what we check for in something like Grafana?
Yes, yes. Yeah, or maybe there was an error in when developing this, and you never really accounted for this screen size, so you just did it like that. That happens often, so it's nice to verify that the flows that you are expecting your users to go through are actually being used.
Awesome. Cool. Well, thank you, Fran. And it's a great demo. Thank you to everyone for listening in. And if you'd like to hear more from us, you can please reach out to us at Embrace.